Engineering drawings are meant to document technical items in an unambiguous way. Some technical items contain a lot of geometrical detail, for example, a screw thread. Simplified representations of commonly used items have been introduced to prevent time-consuming drawing of these detailed geometries. A bolt and a nut are the typical example of screw thread. The bolt contains an external thread, the nut contains an internal thread. The thread has a major diameter, a minor diameter, and a pitch, representing the distance between two tracks of the thread. When an external thread is drawn from the side, the outer contour of the part is drawn using the thick continuous line type. The thread is indicated by a thin continuous line, indicating the minor diameter of the thread. When an external thread is drawn from the front, a full circle drawn using the thick continuous line type shows the outer contour. Inside this circle, a broken circle is drawn, indicating the minor diameter. An internal thread is drawn similarly, but now the minor diameter is drawn using thick continuous lines. The outer lines are drawn with thin continuous lines to indicate the major diameter. Just like an external thread, an internal thread is indicated by a broken circle when it is drawn from the top. The broken circle is located outside of the thick continuous full circle, which represents the whole contour. Note, the thick lines represent the peak of the thread dent, where the thin lines represent the thread roots. When a hole is drilled in a metal part to be used for an internal thread, the drilled length should always exceed the thread length. Imagine the tool used for tapping the thread. It will have a tip which needs space. If this space is not available, the desired thread length cannot be reached. A blind hole with thread in a section will typically look like this. The thick continuous lines show the contour of the drilled hole. A cone is created by the tip of the drill at the bottom of the hole. The projected outlines of the cone form a triangle. The thin continuous lines indicate the major diameter of the thread and stop before the end of the hole, thus leaving space for the drill tip. An assembled screw thread is shown respecting the exception for cutting bolts in a section. The bolt with its external thread is drawn in the foreground, the hole with internal thread is shown in the background. The line indicating the major diameter changes from thick to thin where the bolt ends and continues to indicate the thread root in the hole. Similarly, the thin line indicating the minor diameter in the bolt changes to a thick line at the end of the bolt. Another simplified representation for items commonly used in engineering is the conventional representation used for springs. Instead of drawing every detail of the spring, a zigzag line can be used. A leader showing the diameter symbol indicates that the spring should be made out of round wire. If a square wire is used, a square symbol is shown at the leader. Springs are cylindrical items, so a center line should also be drawn. Bearings are commonly used in any structure in which a part rotates. A section of a ball bearing should be drawn with hatched areas to indicate the inner and outer rings and circles representing the balls. These circles may not be hatched, just like bolts, webs, and spokes. Drawing all this detail is time-consuming, so a simplified representation has been internationally agreed. Two squares or rectangles showing the outlines are drawn with crossings in thin continuous lines to indicate a bearing.